Welcome. This week we're going to go over a double drip water system, which is a kind of a classic instrumentation project where two water drips are created a little bit out of time with each other, and they hit a surface, and the recoil of one hits the other one coming in as it forms. To just show you what the water drip looks like, let's. Here's a high-speed image of what a double water droplet looks like in a video. And as you can see, here's this first, I'm going to freeze it here. There's a water drip. Well, let's go back to the beginning. Here's a first water drip that's coming down and it hits a nice little pan that's a few inches deep, and it hits the surface, makes that first cavitization splash, and there's a little tiny driplet on the screen there. And here's the recoil, the first recoil, and it comes up, and it's still in the process of going up when that second water droplet comes down and hits it right in the middle. So right there's that splash, and together they all fall to the ground, and they make this beautiful little patterns that are really fun to photograph. So in the reality of an instrumentation class, this is a wonderful event because there's a lot of high-speed stuff going on, and a lot of timing is very critical for this. And of course, the devil is in the details. There's all sorts of problems that can happen. So in this video, I'm going to kind of work you through what the problems are, how to overcome those problems, and to see them maybe as you've never seen these problems before. So I'm going to be using an Edgertronic camera along with a Kronos camera. I think I'll be using the Kronos the majority of the time here. And we'll look at each of these problems one at a time. So I'll also be talking about the circuits, and I'll talk about how everything is set up as we go along. So the double water drip is circuits that are pretty simple. We're going to use a push button, which is just wired up here so that when it's pressed, it's going to send a pin high, and it does that with there's actually a pull down resistor, and 5 volts on the other side of the switch that allows it the logic to see 5 volts when the switch is pressed. On the other side is this reed relay, and the reed relay is a mechanical switch. It takes around 5 or 6 milliseconds to respond. That's okay as long as we know what that response is and we can work with it. They're fairly inexpensive, and I like using them in the lab because my students, if they mess up, they chirp. They make a little bit of a chirping noise, and we know that the reed relay has been activated. Later on, we can use power MOSFETs to be quicker, but a power MOSFET is a little bit more expensive. So on this side here, this goes to the controller, the Arduino on the bottom here, and this pin right here, the colored pin, would be the logic from the Arduino, and the blue pin would be the ground. Up here we've got the pins that go to the dripper, and the dripper is a solenoid switch, and I put a diode across the solenoid to make it collapse a little bit faster. I'll talk more about that. So the circuit's pretty easy. So if we start talking about what the dripper is, here's the dripper, and it's a solenoid here, which is controlled by 12 volts. So that goes through the reed relay, and it opens up, and it's pretty quick. These were surplus, so in the lab I have a pile of about 30 of these, and they're not the world's best switches or solenoids for water control valves, but they work pretty well. I think you can spend hundreds of dollars on getting a much higher quality one, and maybe it'll be a little bit better, but not great. So we can modify the pulses that go to these and get a pretty good control out of what happens with this. So the first thing to show you guys is what this drip does as we send 2 different drips to it. And we want to make sure that the drip is only making 1 drip at a time even though those two drips are separated by a certain amount of time. So I'm going to pause this. We're going to go to screen sharing, the desktop, and we're going to come over here to this screen. So on this screen, what I have is a series of videos, and these videos are going to show what happens with the dripper. Now the drip is going to get 2 pulses. So here's the first test, and you can see that it's supposed to get 2 pulses. I'll pause it right now. And here's this, you see these little tiny bits that are coming out, and that's an indication that the pulse isn't correct. And this is another indication that the pulse isn't correct. Here's the second drip, but it has a little tiny drip following it. And this is an indication that the valve has a pulse that's too long and letting too much water to flow through. And in this case, the pulse was 60 milliseconds. And so it's got to be shortened. So I'm going to shorten it, and we'll see what happens in the next video. So I'll close that video. We'll go back to the next video in our sequence. And I've chopped that time down here to, I've decreased it by about 4 or 5 milliseconds. So we can see that this one, as it goes through, there are these little tiny drips in front of it, which are bad. This one looks okay. These are bad. And here's that second one, which is probably a little bit too big. So it's those multiple little drips in the middle that kind of get you. So that's an indication that the valve is open for a little bit too long. So let's decrease the time. And that's this next video, where we're going to have that adjusted a little bit smaller. So there's the first drip, not too bad. Here's the second drip, also not too bad. You're gonna always get these little tiny splashes at the end, so don't worry too much about those. What you really want is 2 nice solid drips. And in this case, I think it's like 42 milliseconds for each drip to be formed with this. Let's keep going with some of these other videos and see where it leads us. So here's another one. Once you get the timing right, you really want to just verify for a couple more splashes, and that's what's going on here. This is the second group at the same time. It looks really good. There are these little tiny drips, but they're livable. We can do some nice experiments with them. So the first step here is to make sure your dripper is dripping correctly. By the way, this is with a Kronos camera shooting at 2800 frames per second. So it's a nice way of visualizing. Now, I realize that everybody doesn't have that capability, but you can shoot these with an iPhone in a high-speed setting and get a pretty good idea of what that drip is doing. Also, you'll see what this drip does as you end up taking the pictures in the double water drip sequence. So let's talk about the double water drip stuff. Here's a typical first step of a water drip, and it's good to talk about this. This is how you pull focus on a double water drip. I have a little pencil set across here, and this is our school photography pencil. What happens is that splash hits the side of this pencil, so it gives me a place to focus on. And this is how I make sure that the framing and the focus is correct. Here I'm focusing exactly on the center of the drip. On higher magnifications, I might want to focus on different parts of the drip. But this is a quick and easy way of just pulling focus. You can use a chopstick or something like that. So, in fact, we'll close that one, and then we will go back to this one. So now let's spend some time looking at these water drip timings. And I'll also talk a little bit about the code. And what I'm going to do here is I'm going to change the code so that the timing between the two drips is adjusted. And what I mean that is that there's a time that these two drips are apart. So here's the first drip that comes down, hits the surface, does the recoil somewhere there, and it's still growing. This drip is still growing in size when the second drip comes down. And this is where that artistic part comes into play. What part of the drip do you want to have it? I'm going to adjust this sequence so that this recoil is growing just when this second drip comes down and hits it. So as we go through it, it's still growing here. This top will separate into its own drip when it's adjusted. And there's a second drip coming down, and they'll hit each other. They often don't hit each other nice and evenly, so they splash on the side. You get that. Sometimes that itself is a really kind of cool splash pattern. I can just play the whole thing right there. So obviously we have too much fun with double water drips. So now what I'm going to do is I'm going to change that timing. That timing was 40 milliseconds. I'm going to increase it to 45 for this next one. And it turns out that these times are pretty much dependent on the recoil of this drip hitting the surface. The depth of that water affects the recoil as well as the viscosity of the water, which is temperature dependent. So you will have to adjust these each time you set up the rig. And here's that first drip hits, there's the recoil, there's the second one hit, and then the whole pillar collapses. So if we go back and we look at this frame by frame, we see that, oh, this is kind of cool. There's some bubbles trapped in here. And since this is in free fall, it's governed by surface tension, and the bubbles can be inside the little sphere, which is kind of a cool effect. You can see that on the International Space Station. They do those zero gravity fluid experiments. So it comes in here and it hits, and this is that two driplets hitting each other. There's a real quick little splatter there. And there it grows into its little top hat kind of stuff. So I think it's still the timing is still a little close. So what we're going to do is increase the timing to here 50 milliseconds and see where that takes us. So this next one, 50 millisecond separation. And here's the first one. Recoil grows, second one comes in and hits. And that looks pretty good, but if we see it, we can see that there's not an exact separation here. This sphere or a driplet is not separated from the recoil column yet. So we're going to give it another 5 milliseconds or 5,000ths of a second to try to separate, which will be the next video. There we go. It's all cool. I mean, this is why we study instrumentation. Okay, this is up at 60, and we'll make this a little bit bigger. So there's 60 milliseconds, and this is actually just beginning to get the separation. As we come through here, we'll see right there that this sphere is not pinched off from the column yet. There's the incoming one, and there's the splash. So let's give it just a little bit more time to see if we can separate them. So we'll increase it by another 5 milliseconds. And so here we go. It's increased a little bit more in time to see if we can actually see it separate. And there's the column form. There's the one coming down. So once again, it's really, really, really close. This is still not separated from that column, so it needs a couple more milliseconds, and then it will. So here's that splash, 2,800 frames per second as it goes. So we will stop this again and go back to our next one as it slows down. That was too fast, obviously. It's like there's a column and it just separates there when that second one hits. So here's, let's go look at that separation. So there's this wick. As it's pulled up, the column has now separated from its, somewhere in there. This column is just about separating when it hits. And then you get the two splashes, they go out. And sometimes this is a really nice place to operate for doing your double water drips. Let's move it another 5 milliseconds out and see what happens after that top sphere separates from the column, and see what that looks like. So here's that video, and there's our first water drip coming in. There's the beautiful recoil. Oh, this is a mess. So here's, things aren't so good here. That first drip that was formed two drips. And these two drips are going to interact with each other on the surface. And that will make this recoil drop not beautiful, nice and even. So when that second drip comes in, they're going to hit off center. And, you know, it may be artistic or something like that, but this is what you get. Things don't always behave the way they do each time. There's a little bit of variations, especially in those drips. So let's just play that one again because it's kind of cool. Recoils, that splash, and that collapse. So let's see another one of those. I shot a couple of those because I knew that one wasn't as good as it could be. So we'll bring in our last one, and that is looking at the recoil right there, separates, another one coming down and hits. And so that's probably a little bit further out in the timing between the two drips than what you might want. And that's, in this case, it's 70 milliseconds. So here's it is running backwards. It comes in and hits, and then you get that quick little splash. And remember, as you set off your high-speed flash for an individual high-resolution still, you can really pick any one of these timings, any one of these individual frames could be your full-size frame. So it's kind of important that you know how this whole thing works together to figure out what timing you want when you pick the timing for your still. So there it goes. So we'll let this one play, hit, fall back down. Taken with a Chronos at 2,800 frames per second. So we're going to stop here, and we'll continue to talk about a couple other things.